Hey guys, the question wants to know which of the following ions is not stabilized by resonance. So be very careful. It's the one that doesn't have charge delocalization through resonance. So if you draw these structures, don't be picking the first one and say, oh, it has resonance, so that's my answer. It's the one that doesn't have resonance. You want to be careful for that kind of wording on your exam. So I think the best way to go about this is to just try to draw resonance structures for each answer and then kind of ask yourself, which one is the answer from there. So if you look at A, you can very clearly see that we're going to draw a resonance structure like that, which gives us the plus charge there, and then we can go ahead and do it again, and we get the plus charge there. So definitely A has the charge delocalized over 3 atoms, so therefore A is going to be stabilized by resonance, so A is out. B is the same thing. B can resonate that way and give you the plus charge here. And what's more is actually you can take the lone pair of B and make a double bond there and then put the plus charge on the nitrogen. So again, this is delocalized over 3 atoms, so B is out. C, actually, it's not shown, but C, since there's a negative on the carbon, that means there's a lone pair there. And we can say lone pair to bond, bond to lone pair, and we get the negative charge there, negative charge over there, and the double bond here, like that, okay? So C is also out. Let's look at D. D is interesting. D has a positive charge on this nitrogen, and there's the alkene here, so it kind of looks tempting to say, okay, this alkene is going to jump this way to sort of make that negative charge goes away, to delocalize that negative charge. But actually, we can't do that because there's nothing to move on this nitrogen. The nitrogen has only single bonds. Remember, in resonance, you can only move double bonds. You cannot move a single bond in resonance. And so therefore, if we move this guy in here, we'd break the octet rule. See, because there's already 1, 2, 3, 4 bonds to the nitrogen. So we're stuck. We cannot move this positive charge off the nitrogen, at least not with anything in here. And so therefore, that's it. There's nothing we can do. So the charge will be stuck on that nitrogen only. So this ion is not stabilized by resonance or by electron delocalization. So therefore, D looks like is going to be my final answer. Let's just confirm that E is the answer. So with E, again, we have the negative charge. So there's a lone pair there, right? Looks like that. And here's the bond here. So I can again say lone pair to bond, bond to lone pair. And that gives me this compound here with the negative charge over there. So again, E is stabilized by resonance, so E is also out. All right, so my final answer will definitely be answer choice D. All right, thanks guys. This was a fun one to do. If you have any questions, feel free to shoot me an email. I'll be happy to explain things in more detail. Make sure you are 100% comfortable with the idea of resonance before walking into any chemistry exam. Have a nice day.